Okay, vector algebra is a very important topic. Okay, it comes in mains and advanced, very important, even in IP also. And you have to be thorough with this chapter in the first year itself. Okay, because for example, straight lines concepts or differentiation concept we will be using in second year also. When we study circles chapter in second year, automatically we will be using all the straight line formulas. When you study integration in second year, you will be using all the differentiation formulas. But vector algebra and 3D geometry, these are the two topics where very important, but only we will do at the end of second year in division only. Okay, so you have to learn for the first time only thoroughly. It is actually easy topic to some extent in the beginning because you already in physics you have some idea about vectors. I don't want to tell everything from the beginning, right? Okay. So anyway, you can just what is today? Today is 28th. Okay. In this total, we have four subtopics. One is addition of vectors. Another one is dot product of vectors. Another one is cross product of vectors. Another one is triple products and multiple products. These are the four chapters in IP within vector algebra. In that, for this year and last year, due to COVID, for IP board exam, they removed the fourth topic, which is triple product of vectors. Okay, but still we'll discuss this extensively. Okay, because it is very useful for mains and advanced also. But in one sense, IP exam on this topic will be quite easy because addition, dot product, and cross product are all quite easy topics. Okay, only triple products is a little complicated, but we will discuss. Okay, so our first topic is addition of vectors and the basics also. Addition of vectors and the basics of vectors. Okay, I am not going to write every small definition. Many things are there in the textbook. They are there in your mains material. I may ask you write only few things. Okay. Okay. Now, what is vector? You studied in physics also to some extent that any quantity which has both magnitude and direction. Okay, and which follows some laws of the vectors like addition laws and all is called vector. Just because it has magnitude and direction, it doesn't mean it is a vector. I think general common example they give is current, electricity. It has magnitude, it obviously has a direction, but we don't treat it as a vector. It is not that you have a wire, in this 2 amperes current is going, in this 2 amperes current is going. You can replace with a wire with 2√2 amperes like this. It is not like that, no? Okay. The wire can be bent in any way. The current that goes is always same 2 amperes only. Okay. Does anybody know any physical quantity which has different magnitudes in different directions? It has magnitude and direction, but if you change the direction, magnitude changes. That is, there are many quantities. One of them is angular momentum. When you rotate, your I changes, right? Momentum inertia changes based on the axis and based on the rotation. Then if I changes, I omega changes or MVR changes. Okay. So angular momentum is not a vector. It is tensor. Tensor is also another quantity in physics which has magnitude and direction, but in different magnitude it has different directions. Okay. So at higher level in physics, the tensors are studied quite extensively. Even in maths, to deal with the tensors in physics, we have whole tensor calculus. Okay, but that is at higher level, so don't worry about all that. Okay, fine. So anyway, basically vector means it has magnitude and direction. Okay, so the way things went in IP textbook. Okay, if I go in that order, just to do first exercise will take a lot of time. I have to tell a lot of theory, but till some days I cannot give any homework. Okay, so I am not going in a proper order. I'll come back to the proper order. I just want to, because you have some idea about vectors, I just want to tell few basic things. Very first point, everybody knows this. If A bar is equal to xi plus yj plus zk, then mod A bar is its magnitude, which is root over x square plus y square plus z square. Okay. So now, normally I don't start with this because I have to tell you what is ijk first of all. The unit vectors along x-axis, y-axis and z-axis. And I have to tell why every vector is written in terms of ijk. The reason why it is, I have to explain all that, which I will explain later. Okay, everybody knows this. Now, second point. If you know one vector is a bar, any other vector parallel to that is definitely a multiple of a bar. For example, if this length is 5, parallel to that, if there is a vector in the same direction, it will be, let us say, 10 units. Then, how should I write in vector form in terms of a bar? 2a bar, because this length is 5, this length is 10, double the length. Okay. If there is a vector like this, whose magnitude is 20 units, how should I write it? No, it is opposite direction. So, minus 4a bar, right? Okay. So, if you multiply with a positive quantity, you are not changing the direction, but you are changing the magnitude. If you are multiplying with a negative quantity, it is still parallel vector, but direction changes, right? Okay. So, unit vector in the direction of a bar is, if you want a unit vector, let's say this magnitude is 5, only when you divide is 5, it will become a unit vector, right? Okay, so unit vector in the direction of a bar, generally we call it as a cap. Formula for that is a bar by mod a bar. Okay. If you want unit vector parallel to a bar, parallel means the direction can be same or opposite. Okay, is plus or minus a cap, which is plus or minus a bar by mod a bar. If you want vector of magnitude k units, vector of magnitude k units and parallel to a bar, it is plus or minus k into a bar by mod a bar. Okay. If there is a vector a bar, divide with mod a bar, what you get is a unit vector. If you multiply with k, what the magnitude will be? K units, right? Okay. These are simple points, but I want you to write them. So in the class notes, please write these points. Anybody has 1 year textbook? Thank you. Okay, fifth point, whenever two vectors are parallel, okay, definitely we will be able to write this vector as some number into this vector. We discussed already. If there is a bar, any parallel vector, it can be 2a bar, 3a bar, 5a bar, or 100a bar, or minus 5a bar. Okay. So if two vectors are parallel, definitely the second vector you can write first vector into some number. Okay. Or you can write, let's say if I write 7a bar plus 3b bar equal to 0 bar. From this also I can tell it is they are parallel vectors, because then 3b bar that side and divide with 7, we get a bar equal to some number into b bar. That's what I am writing. If a bar and b bar are parallel, there exists some real numbers lambda, mu, gamma such that a bar can be written as some number into b bar, or some number into a bar plus some number into b bar equal to 0 bar. Both carry the same meaning. Okay. Almost following this result, if a1i plus a2j plus a3k is one vector and b1i plus b2j plus b3k is another vector, okay, when they will be parallel vectors, is the ratio of I coefficients, ratio of j coefficient, ratio of k coefficient. If they are equal, they are parallel. Okay. How to prove that? Just now I said, whenever two vectors are parallel, you can write one vector is lambda times another vector. So I just wrote that and multiply and compare I coefficients, you will get this equation. Compare j coefficients, you will get this equation. Compare k coefficients, you will get this equation. What is lambda from first equation? A1 by b1. Lambda from second equation? A2 by b2. From third equation? A3 by b3. So simply the ratio is equal. It is something like in 3D geometry. If one line has two sets of dr, the dr's ratio should be same. Okay. Those are online. You are able to follow. Please respond. Okay. Is the board clearly visible to you? Okay. Those are physically there. For anybody, is the phone blocking your board? No. For you. But you can bend this way, that way, manage. Okay. We mean it need transparent mobile and transparent stand. In vectors chapter, whenever you say two vectors are collinear, that means they are parallel, because vector doesn't have a fixed place. Let's say this vector is a bar. If you move it like this parallelly, it is still a bar only, because this vector and this vector have same magnitude and same direction. As long as two vectors have same magnitude and direction, they are equal. Okay. So now, whether I write a bar like this and b bar like this, or a bar like this and b bar like this, there is no difference. If I write like this, I may say they are collinear. If I write like this, I may say they are parallel. But actually, both carry same meaning. In vectors, not points. Vectors collinear, vectors parallel. Both are same meaning. There is no difference. Okay, everybody completed this? Those are online completed? Okay. Okay. Please listen. Like in 2D geometry, every point we call it as x comma y. In 3D geometry, every point we call x comma y comma z. Okay. How to represent a point in vectors? You take a point, it doesn't have any magnitude or direction, right? Only one null vector, like one point. Start for every vector, you have a starting point and ending point. It has some length and it has some direction. Okay. But if you take only one point, you cannot represent as a vector. But by using vector algebra, I want to specify the different points in space. So what to do is, you join everything to origin. Okay. OP bar is called position vector of point P. Okay. You take any point in the space, join to origin, you will get one vector now. Okay. OP bar, because the point cannot be represented as vector, we are joining to origin. From origin to P, there is a vector. Okay. If you tell that, for example, if somebody tells you OP bar equal to 4i plus 2j plus 3k, that is sufficient. It tells you that along x-axis travel 4 units, along y-axis travel 2 units, along z-axis travel 3 units. That point is point P, right? Okay. So joining any point to the origin, okay, that vector is called the position vector of point P. Even the point cannot be represented vector, joining the origin we are representing, so that we can tell you where is that point. It's like telling the address. Okay, along x-axis how much to travel. Okay. Same thing in 3D geometry. If you want to tell the coordinates of this point are 4, 2, 3. There is no difference between vectors and 3D geometry. If you put ijk, it is vectors. Remove ijk, it is 3D geometry. That's all. Okay. Okay. Now, whenever you want a vector joining A and B, I can give position vector of point A, point B, point C, point D. If you want AB bar, it is OB bar minus OA bar. That is position vector of the second point minus position vector of first point. Position vector of point B minus position vector of point A. This actually, how this came, you can actually see in the figure, very simple. We don't need anything. This is, you can take longer also. This is O, this is A, this is B. Okay. I don't have to state triangle law and parallelogram law, these laws. Everybody knows in physics you studied this. If this is a parallelogram, if this is A bar and this is B bar, what is this vector? A bar plus B bar, right? Okay. In a parallelogram, if two adjacent sides are A bar and B bar, the main diagonal passing through this point is A bar plus B bar. Next, if there is a triangle, this is A bar and this is B bar and this is C bar, all are in the one direction. Then A bar plus B bar plus C bar equal to 0 bar. Okay, this is triangle law. You can also define triangle another way. If this is A bar and this is B bar, okay, The third side don't take in the same, you take in the opposite direction, what you get is a plus b. Okay. So now coming back to this, so the parallelogram law, triangle are very simple things and you learnt in physics, right? So that's why I'm not defining them. Otherwise, you should define them first. Other, how can you talk about addition of vectors? Okay. Now coming to this is OA bar, this is AB bar, and this is OB bar. Okay. Can I say this vector plus this vector will give me this vector? Okay. So I can write OA bar plus AB bar is equal to OB bar. You don't even need figure also. Here it is ending with A, this is starting with A. So forget about that. Let us say I write OP bar plus PQ bar. Without any figure, directly I can write OQ bar, because where is O, where is P, where is Q, I don't care. OP bar is this, PQ bar is this. Directly OP plus PQ will give me OQ. That is the triangle law. Okay. The same way OA plus AB is OB. Send OA that side. You will get AB bar is equal to OB bar minus OA bar. We will be using this repeatedly. Whenever you want MN bar, you have to write ON bar minus OM bar. Position vector of second point minus position vector of first point. Okay, just write this statement and the explanation for that. Okay, this we could write by triangle law. By triangle law of vectors, OA plus AB is OB, send OA to the other side. Those are online. I hope you are writing notes properly. Maybe this is the first chapter. I am giving some notes. Till now, I am just orally discussing the theory and only discussing questions. Okay. Okay. In 2D geometry, if I give 3 points, 2, 3 and 5, 7, some 20, 23, how will you prove whether they are collinear or not? You can take area of triangle is 0. You can take slope of AB equal to slope of BC. Or you can find AB distance, BC distance, EA distance, one will come sum of other two. How will you prove in 3D geometry if this is 2, 3, 5, 5, 7, 9, 20, 23, 14, whether collinear or not? You will find drs of AB, drs of BC, their ratio should be same. How will you do this in vectors now? If the position vector, let's say origin is here, OA bar is 2i plus 3j plus 5k, OB bar is 5i plus 7j plus 9k, and OC bar is 20i plus 23j plus 14k. I'll give you position vectors of 3 points. How to prove they are collinear is you find AB bar, which is OB minus OA. You find BC bar, which is OC minus OB. You will get two vectors, AB bar and BC bar. If AB and BC are parallel, then the points ABC are collinear. That's what I wrote. Points ABC are collinear if AB bar is parallel to BC bar. How will you know whether two vectors are parallel? I coefficient ratio equal to J coefficient ratio equal to K coefficient ratio. Okay, just I mentioned that theory, that's all. Okay, everybody completed? Okay. If you let us say in a plane, let us say this is a board or a plane in which you know two vectors a bar and b bar. Any other vector in this plane can be written as a combination of a and b. Okay. For example, this vector is there. This can be definitely written as some number into a bar plus some number into b bar. How? Parallel to this, you draw one line through this and one line through this. Parallel to this, you draw one line through this and one line through this. Now, is that a parallelogram? Because this is a bar and this is parallel to that, is some multiple of a bar. Let us say it is 5a bar. Because this and this are parallel, if this is b bar, this is some multiple of b bar. Let us say it is 3 by 2 times b bar. And using parallelogram law, this one will be sum of these two. In a parallelogram, the diagonal is sum of the two adjacent vectors, right? So 5a bar plus 3 by 2 b bar is that. Let us say somebody says, how will you express this vector in terms of this? Again, through this you draw two parallel lines to a bar. Through this you draw two parallel lines to b bar. This vector plus this vector sum will be this vector. This is a bar, but this is like this. Maybe it is minus 2a bar. This is like this and this is like this. Maybe it is 3b bar. Add these two, will get this vector. Okay, which is minus 2a plus 3b. So every vector in this plane can be written as some multiple of a bar plus some multiple of b bar. That means lambda a bar plus mu b bar. If you keep on changing lambda and mu, it will cover all the vectors in this plane. But if somebody says there is a vector like this in the space, expressed in terms of a bar and b bar, not possible. Whatever number you take into a bar plus whatever number into b bar you take, you can never get a vector which is outside this plane. You can only get this vector, this vector, this vector, this vector, this vector. You can get this direction, this direction, this direction, this direction, this direction, which is in the plane. If you want to express some vector in the space, if you know two vectors, not sufficient. You should know three vectors in the space. Okay. If you know three vectors in the space, every other vector in the space can be written as a linear combination of them. That means something into this plus something into this plus something into this will give you that. How is that? Imagine I am drawing a figure. It is actually called a parallelepiped. What is this parallelepiped? It is also like a rectangular box. You take a rectangular box where all the six faces are rectangles. Imagine a similar figure where all six faces are parallelograms. The front face and back face are parallelograms and they are parallel. The left and right are another parallelograms and the top and bottom are another identical parallelograms. Okay, that is called a parallelepiped. Okay, so this is one parallelogram. This is another parallelogram, and I want to join like this and like this and like this and like this. Okay. If you want this vector, if this is a bar and this is b bar and this is c bar, this is a plus b plus c. Why? If this is a bar, this is b bar, according to parallelogram law, this is a bar plus b bar. And if this is c bar, this is also c bar. This is a plus b and this is c. According to triangle law, what is this will be? A plus b plus c. Okay. So a bar plus b bar plus c bar is this. Now, if you know three vectors in the space and any other vector in the space you want to write in terms of these three vectors, you can write, because imagine a parallelogram where this is the like a body diagonal of that. Okay. This is some multiple of a bar, this is some multiple of b bar, and this is some multiple of c bar. When you add them, you will get this. Okay. So if d bar is one vector in the space and a bar, b bar, c bar are three other vectors in the space, definitely d bar can be written as lambda a bar plus mu b bar plus gamma c bar. But these three vectors should not be in one plane. Let us say a bar is like this, b bar is like this, and c bar is like this. Then you take something into a bar plus something into b bar plus something into c bar, will cover only vectors in this plane. It doesn't cover outside the plane. So If C bar is not in this plane, it is like this, then their linear combination will cover every other vector in the space. In fact, this is the reason we have to define ijk. Unit vector along x-axis I, along y-axis j, and along z-axis k. Once you know ijk, any vector in the space can be written as some multiple of I plus some multiple of j, some multiple of k. When you add them, you will get that vector. That's why we take general vector as xi plus yj plus zk. If you want any vector in only xy plane, you don't need k. Any vector in xy plane will be in the form of xi plus yj, no k term, because you know two vectors is sufficient. If you know I and j, everything else is a linear combination of I and j. That's why all the vectors in xy plane are covered by xi plus yj. All the vectors in the space are covered by xi plus yj plus zk. That's why we write every vector as a1i plus a2j plus a3k, something like that. If you take any two vectors in the space, they are always in one plane. If you take any two vectors in the space, they are always in one plane. Let us see whether this statement is correct or not. You take these two vectors, this is a bar and this is b bar. Are they in one plane? Is there any plane containing this vector and this vector? This is a bar and this is b bar. Is there any plane containing a bar and b bar both? No, right? Yes, there is a plane containing a bar and b bar. What is that? You said no. Okay. But just now I said statement that any two vectors in the space are always coplanar in one plane. How is that? Is that vector doesn't have fixed place. If a bar is here, I can move it, this a bar. Now are they coplanar? A and B, there is a plane containing them. They are forming like a T. There is a plane, right? Okay. So please understand vectors can be moved. Okay. Let me ask another question. I have a vector d bar. Perpendicular to that, there are three vectors. A bar is like this, B bar is like this, and C bar is like this. Is A, B, C are in one plane or they are not in one plane? This is d bar. Perpendicular to this, there are three vectors. One is A bar like this, one is B bar like this, and C bar like this. I am saying A, B, C are coplanar or not, I am asking. Is there a plane containing A, B, C? Yes. Let's say this is A bar. If B bar is here, you can move it all the way down. It is B bar only. If C bar is here, you can move it all the way down. So this is A, this is B, this is C. They are in one plane or not? So if three vectors are perpendicular to one vector, those three vectors must be coplanar. They should be in one plane. Correct? Okay. Anyway, I'll give you three vectors, A bar and B bar and C bar. This vector is I plus 2j plus 3k. This vector is 7i plus 9j plus 4k. This vector is 3i minus j minus k. I will ask whether they are coplanar or not, because three vectors, they may be coplanar, may not be coplanar. Two vectors are always in one plane, but not three vectors. Let's say I have three fingers, okay, three vectors like this. Even though you can move them, okay, parallelly, you cannot make them coplanar. Sometimes three vectors in the space, one like this, one like this, one like this, can be coplanar. How to verify? There are two methods. One is take this determinant equal to 0. 1, 2, 3, 7, 9, 4, 3, minus 1, minus 1. If this det is 0, they are coplanar, otherwise they are not coplanar. But what is the connection between det and coplanarity? Will be studied in the triple product. That is the 4th chapter of this topic. Okay. At this stage, if you want me to tell a method, whenever three vectors are coplanar, I should be able to write one vector as a linear combination of other two. So that is I plus 2j plus 3k is lambda times 7i plus 9j plus 4k plus mu times 3i minus j minus k. Equate I coefficients will get one equation, equate j coefficients will get one equation, equate k coefficients will get one equation. Total how many equations? 3. But how many unknowns? 2, lambda and mu. So you don't need 3 equations. Solve first 2 equations, will get lambda and mu. That lambda and mu, put it in the third equation. If they satisfy, then these vectors are coplanar. If the lambda and mu that you got by solving two equations doesn't satisfy the third equation, then they are not coplanar. This is a method that we can do at this stage. But in IP it is quite acceptable that you don't do all these things, simply take det equal to 0 also, it's fine. But why det, I cannot explain now, I have to tell only later. Alright. Maybe I can give some idea. Tomorrow I will tell you why det is giving some idea I will give you. Okay. Alright, thank you. So I am not giving any homework today. Vectors, you can do your properties of triangle and all. Any doubts in properties of triangle you can ask tomorrow in the class, I will clarify. Otherwise I will continue in vectors. We will see later. Okay, thank you.